Good morning, sir.
Students, please be online. Stars are welcome.
Good afternoon, guys. So, as the physics track 2 schedule has been sent to you, already you know that. So, let us go with track 2. Okay. So, the first chapter which was mentioned in track 2 was thermal properties of matter. Okay. So let us small what was there in thermal properties of matter. Let us see. Okay. Thermal properties of matter. Okay. This is our chapter. One of the thickest chapter in the part 2 of NCERT book. Okay. So here, what are the subtopics are there means thermometry. Next one, calorimetry. Next, thermal expansion and heat transfer. Okay. So among these subtopics, heat transfer was not there for the board, but the heat transfer will be there for NEET and JEE. That's why we have to discuss that also. Thermal properties of matter is our topic. Is there any doubts?
No, sir.
So shall we go on?
Yes. Yes, sir.
Okay, fine. So thermal properties of matter is our topic, and in that these are the subtopics are there: thermometry, calorimetry, thermal expansion, heat transfer. Thermometry means the measurement of temperature. As you know that one temperature, the measurement of temperature is known as thermometry. Measurement of heat is known as calorimetry. Thermal expansion means you know that every substance will expand on heating. So here we will discuss expansion of solids, expansion of liquids, and expansion of gases. Next, the heat transfer. In what way the heat will be transferred from one place to another place means there will be three ways are there to transfer the heat. One is conduction, one is convection, and one is the radiation. So with these subtopics, we are going to close this chapter that is called thermal properties of matter. Parallelly, we can focus on JEE numericals also. Okay, guys. So let us go with the thermometry first. So thermal properties of matter.
Sir, your video is breaking.
Okay. Are you able to see?
No, sir, it's
Students.
completely blurred.
It's blur, sir.
Wait a minute. The remaining guys are there in the people. For them, how the video and audio will be?
Sir, now it's clear, sir.
Now it's clear, sir.
Fine, fine. So that might be individual handset problem. You can look for that, those who are having. So it is clear from this side. Okay, so right. So let us see what is thermometry and all. Before going to that, what is mean by heat? Okay, heat, and what is mean by temperature. So what is mean by heat means heat is a form of energy. How can we say that it is a form of energy? Anyone can respond? How can I saying that it is a form of energy? So heat is a form of energy because we are getting the energy by eating the cooked food. Foods almost we are eating the food after the cooking only, or else we are eating the raw food.
Cooked food, sir.
Yes. Okay, so we are supplying the heat energy means we are cooking means we are supplying the heat energy. That is one example. In olden days, nowadays diesel engines and electric trains are there, but in olden days there is only a steam engines are there. There the steam is used to run the train. How the steam will be generated means by burning of the coal. So if the heat energy is supplied to the water will be boiled and then steam will be generated. So there what the energy we have given to generate the steam, that the same energy is used to run the train. Next, similarly, thermal power stations are there. I'm not speaking about hydro power stations. Thermal power stations. There, the steam turbines are there. So the steam is used to rotate the turbine. You know that how the steam is generated by heating the water only. The steam will be generated. So therefore, the steam can able to rotate the turbine means steam will have the capacity to do the work. The steam is used to run the train means the steam will have the capacity to do the work means the steam is having energy. The capacity of doing work is called energy. So if the energy is there, then only we can have the capacity to do the work. If there is no energy means then it is not possible to do the work. So hence steam is successfully rotated the turbine means the steam has done some work. So that the steam has the capacity to do the work. Similarly, the steam has running the train means steam is having a capacity to do the run the train. So that's why steam is having an energy. How the steam is gaining energy means by supplying the heat to it. So that's why what is meant by heat means heat is a form of energy. It is a form of energy. It is a form of energy. Okay. The energy can exist so many forms in the nature. So like sound is a form of energy. I'm going to interact with you guys releasing some sound. That is a form of energy. Light is a form of energy. So energies can exist in different forms in the nature. Heat is among one of them. Heat is a form of energy. The heat will always flow from a body at higher temperature to a body at lower temperature. For example, this is the body A, which was at 80 degrees centigrade, and this is the body B, which was at some 40 degrees centigrade. So usually, how the heat will be transferred means heat will be transferred from the body A to body B. So what is mean by heat means it is a form of energy, so that it can always transfer from a body at higher temperature to a body at lower temperature. By itself, heat cannot transmit from a body at lower temperature to a body at higher temperature. By itself, it is not possible. So, is that impossible? Means, of course, it is not impossible. By itself, heat can be transferred only from a body at higher temperature to a body at lower temperature. But is the converse is true means by itself it is not possible to transfer the heat from body at a lower temperature to a body at higher temperature. But by using some external agency, it is possible to transfer the heat from lower temperature body to higher temperature body. What are the external agencies means refrigerator will do the same. Okay, refrigerator and air conditioners will do the same. Without having the refrigerator, it is not possible to keep the premises inside the refrigerator is cool. Without air condition, it is not possible to have a constant temperature inside the room, which is less than the temperature outside the room. These are the external agencies. With the external agencies, the heat will be transferred from lower temperature to higher temperature, but the natural way of transferring the heat will be from a body at higher temperature to a body at lower temperature. So that is about the heat. So what is an SI unit of heat means, as we told that heat is a form of energy, the SI unit of heat will be equivalent to joule. Okay. So then heat can also be measured in calories. So 1 calorie is equals to 4.2 joules. So this is about regarding the heat. What is mean by heat means, heat is a form of energy. By itself, heat can always transfer from a body at higher temperature to a body at lower temperature. The SI unit of heat, and it can also be measured in calories. 1 calorie is equivalent to 4.2 joule of energy. Okay. So please copy this, and then we can go with the temperature. Okay. So students, first keep submitting the heat. Is it clear, guys?
Sir,
Can you
1
please come
calorie is
aside, sir?
4.2 joules or 42
Students,
joules.
1 calorie. Hello? Repeat the question.
So can you please come aside, sir?
1 calorie equals.
How many joules, sir?
First keep
42 or
submitting. Keep
4.2?
submitting. Just I'll narrate, then you can narrate it. Okay?
Sir, there's disturbance in your video and audio, sir.
It is a form of energy. It is a form of energy. Which one? It is a form of energy which can always transfer from, which can always transfer from, which can always transfer from a body at higher temperature to a body at lower temperature. A body at higher temperature to a body at lower temperature. A body at higher temperature to a body at lower temperature. Make a note of this point. One more point. Note. Is it clear, guys?
Clear, sir.
Make a note of this. By itself, or else wait, without an external agency, without an external agency, without an external agency, without an external agency, it is not possible to transfer the heat. It is not possible to transfer the heat from a body at lower temperature. It is not possible to transfer the heat from a body at lower temperature to a body at higher temperature. It is not possible to transfer the heat without an external agency. It is not possible to transfer the heat from a body at lower temperature to a body at higher temperature. Example for that is refrigerators and air conditioners. Refrigerators and air conditioner. So you can write this. SI unit of heat is joule, and it can also be measured in calorie. 1 calorie equal to 4.2 joule. SI unit of heat is joule, and it can also be measured in calorie. 1 calorie equals to 4.2 joule. 1 calorie equals to 4.2 joule. Okay. So right. Okay, now clear, guys.
Clear, sir.
Right. So let us go with the next, that is the temperature.
Sir, your video is struck, sir.
Okay, now it is one of the fundamental physical quantities which we have studied in the first chapter called units and measurements. There we have discussed about the 7 fundamental quantities and 2 supplementary quantities. So this temperature is among one of those 7 fundamental quantities like length, mass, time, electric current. Temperature is among one of them. How can we define the temperature? Means it is the measure of hotness. Okay, it is the measure of hotness or coldness. Hotness or coldness. The measure of the hotness or coldness of a matter or a body, that is known as the temperature. Remember, students, temperature is always measured by comparison. Temperature is always measured by comparison. Okay, so I'll give the notes, don't write. So first listen first. So then, for example, I have taken 3 beakers. So in the 3 beakers, the water is there. Okay. So here the water was at 40 degrees centigrade in the vessel A, and there is another vessel B. Okay. So here the same water is there, which was at some 60 degrees centigrade, and the water C. Okay. So this is the vessel C. This is vessel B, which was at some 80 degrees centigrade. So which one will be the hottest among these 3? Either A or B or C?
C, sir.
See,
C. Yes, good. What about B? Can I say that it is a cold one, cold body or hot body?
Hot body itself, sir.
Hot body, no. Even it can be a cold body also. Listen, when compared to the water in the vessel A, the water in the vessel B is hottest. When compared to the water in the vessel C, the water in the vessel A is coldest. That's why temperature can also be measured by comparison. So the hotness or coldness means with respect to the atmosphere. For example, with respect to the atmosphere, we can say that it is a cold or hot. So that is about it is a measure of hotness or coldness, that is known as the temperature. So is the temperature is a scalar or vector quantity? Means temperature is a scalar quantity. Temperature is a scalar quantity. How can we measure the temperature? Means we need an instrument to measure the temperature. That instrument is known as thermometer. Okay, so that is known as thermometer. We have different types of thermometers are there. Liquid thermometers are there. Next, gas thermometers are there. Okay. So and the resistance thermometers are there. Different types of thermometers are there. So let us see one after the other, one after the other. It keeps updating temperature. Okay. Temperature. It is the measure of. It is the measure of the hotness or coldness of the object. It is the measure of hotness or coldness of the object. Comma. Temperature is a scalar quantity. Temperature is a scalar quantity. Temperature is a scalar quantity. Okay. And one more point also we can discuss here. Temperature is the measure of heat transferring ability also. So if the body is at higher temperature, means for example, your 2 identical bodies are there. This is the body some X and this is the body Y. Okay. So this is at some 180 degrees centigrade. This is at 60 degrees centigrade. So here, which can transfer the more heat in less time means the body X can transfer the more heat in less time because its temperature is more. The body Y also can transfer the heat, but not similar to the X. Okay, so that's why here the heat transfer ability of the X is more because X is at more temperature than Y. That's why temperature is also represents the heat transfer ability of an object. If the object is at more high temperature, the heat transferring ability of the object is also more. If the object was at less temperature, the heat transferring ability of the object is also less. So this is about that is also we can write it. Heat transferring ability is also. So let us next keep subheading scales of temperature. So, okay, so scales of temperature. Scales of temperature. So generally, how many scales of temperature means either temperature might be measured in degree Celsius, or might be measured in degree Fahrenheit, or might be measured in Kelvin. These are the three scales we know about this. Temperature that can be measured in degree Celsius, a temperature that can be measured in degree Fahrenheit, a temperature that can be measured in Kelvin also. Generally, the atmosphere temperature will be measured in degree Celsius. The temperature of our human body is measured in degree Fahrenheit. In laboratories, the temperature will be measured in Kelvin. So then, how can we design a Celsius scale, and how can we design Fahrenheit scale, and how can we design a Kelvin scale? Means first of all, how to design a scale means. So the designing of the scale will consist of three steps. First one is what? The first one is
Sir, you're muted.
Sorry, muted, sir.
now it is okay.
Yes, sir.
So yeah, LFP means lower fixed point. Next, UFP means that is nothing but upper fixed point. Upper fixed point. Next one is fundamental interval. Okay. So here third one is division of the fundamental interval. These are the three important steps are there to design a scale of temperature: lower fixing point, upper fixing point, and the division of the fundamental interval. What is mean by lower fixing point means see here students you can take your different references. Generally, lower fixing point means melting point of ice. Okay, melting point of ice that can be taken as lower fixing point. Next one is boiling point of water. Boiling point of water that can be taken as upper fixing point. How to mark means, so for example, let us see this with this example. So this is a thermometer. This is a thermometer. So in which the mercury is there. Okay, so then how to mark this LFP and UFP means if this thermometer is dipped in a beaker that consists of melting ice, that consists of melting ice. So then in that case, then what will be happen if we are allowed to like this? Then what will happen means the mercury will be level will be fixed to somewhere else. Here is the mercury. When this thermometer is kept it on the melting ice. So this is known as LFP. So successfully we have marked the lower fixing point.
Sir, you're stuck.
Here another beaker that consists of boiling water. So boiling water means definitely the level of the mercury in the thermometer will not be at this mark, it will be raised to some other level. So now we notice that when we are so it is kept in a boiling water, so this is the boiling water. If you are kept in a boiling water, we notice that the mercury was at this point. This is known as UFP, upper fixing point. So then successfully we have marked lower fixing point. Successfully we have marked upper fixing point. So lower fixing point means generally you can take your own reference. So it will be there is no rule that the melting point of ice is only the lower fixing point. Such rules are not there. You can take it to any reference. Generally, for the melting point of ice, the reference point, the melting point of ice will be taken as lower fixing point. For example, this is the thermometer. If you are if you are dipped vertically in the beaker consists of melting ice. So then, if the thermometer is allowed a certain time like this, then definitely the mercury in the thermometer will be fixed to that particular level. This is the point where the mercury is there, and this thermometer is kept here. Then this is known as the lower fixing point. We have marked the lower fixing point successfully. Now this thermometer is taken out from this beaker, and here we have placed in another beaker. There water is boiling. Water is boiling when we are placed means what will be happening? Heat will be transferred from water to the thermometer. By that heat, the level of the mercury by expanding that, the level of the mercury in the thermometer will increases, and after certain time we notice that this is the point. From here onwards, the level of the mercury is not increasing. So that's why this is the point we have marked as upper fixing point. At this point, the water will start boiling. At this point, the ice will start melting. That's why this is known as lower fixing point, and this is known as upper fixing point. Now we have successfully marked the lower fixing point and upper fixing point. So then this is called LFP, and this is called UFP. And the gap between this UFP and LFP, that is known as fundamental interval. So Fi also we can write fundamental interval. So division of the fundamental interval means how many divisions you would like to split, that is you can do it. But the gap between the first and second division must be equal to the gap between last and last but one division. For example, here some 200 divisions are there. We have divided into 200 divisions. The gap between 0 and first division must be equal to gap between 199 and 200 division. That must be equal to gap between 99 and 100. So that is the division of the fundamental interval. By doing carefully, by doing these three tasks, then we can prepare our thermometer. For example, if we are not marked the LFP properly and UFP properly, and division of the fundamental interval not properly means, of course we can measure the temperature, but those values are not accurate. We can get the error. Okay, we can get the error. So that's why to avoid that and to measure the temperature accurately, one has to careful about lower fixing point and upper fixing point and division of the fundamental interval while making the scale of temperature. So you can make your own scale of temperature also, some scale X, scale Y, scale M also. All the scales of temperature which we are going to prepare, it consists of these three steps only. Lower fixing point, upper fixing point, and the division of the fundamental interval. So lower fixing point means the reference point at which the ice will start melting, that is known as lower fixing point. The reference point at which the water starts boiling, that is known as boiling point of water, and the division of the fundamental interval. So like this, how can we divide? Means equally. Okay, the space between the any two digits between LFP and UFP must be equal. Then only we will get the somewhat accurate values of the temperature. Otherwise, there is an error with the instrument. Okay, so this is the way of scale of temperature. So please make a note of this. Please make a note of this. Then we can go for different. What are the different scales of temperature? We now let us see. Clear, guys?
Clear, sir.
Okay. So please make a note of this. This is nothing but LFP. Okay. Melting ice. This is nothing but UFP. Boiling water. Scale of temperatures. Is it over?
1 minute,
Yes,
sir.
sir.
Okay, I'm going to of this. Can I? Emma. Can I? Adya, next, Nandan. So please respond. So, is it completed all?
Yes,
Yes,
sir.
sir.
Completed.
Fine. Okay. So let us see what are the different scales of temperature. Let us see. So different scales of temperature. So there are four different scales are there. Let us focus on that. The first one is. So let me write this first. Fahrenheit scale. Next one is Kelvin scale. Last one is Reamer scale. Okay. So these are the four different scales are there. In Kelvin scale, what is meant by LFP means that is nothing but 0 degrees centigrade, and UFP is nothing but 100 degrees centigrade.
100.
After the Celsius scale, the ice will start melting at 0 degrees centigrade and water will start boiling at 100 degrees centigrade. So what about this Fahrenheit scale means on the Fahrenheit scale, the same will be happen at 32 degree Fahrenheit and 212 degree Fahrenheit. According to this scale, the ice will start melting at 32 degree Fahrenheit and water will start boiling at 212 degree Fahrenheit. So the next one is Kelvin scale. According to Kelvin, the melting point of ice is 273 Kelvin. Boiling point of water is 373 Kelvin. And according to Reamer scale, it is the ice will start melt at 0 degree Reamer and the water will start boil at 80 degrees. So these are 0 degree centigrade, 32 degree Fahrenheit, 270 degree Kelvin, and 0 degree Reamer. All are represent the same. According to Kelvin scale, LFP equal to 0 degree centigrade means at this particular temperature the ice will start melting. According to Fahrenheit scale, the lower fixing point is 32 degree Fahrenheit means at this particular temperature according to Fahrenheit the ice will start melting. According to Kelvin scale of temperature, the lower fixing point is 273 Kelvin. According to that, here the ice will start melt at 273 Kelvin. And Riemann scale LFP equal to 0 degree R means the same will happen in Riemann scale. Similarly, these are the upper fixing points. Here, how many divisions are there in the Celsius scale means there is 100 divisions are there between LFP and EFP. And here, how many divisions are there means here 180 divisions are there in the Fahrenheit scale, and here in Kelvin scale, there are again 100 divisions are there between LFP and UFP. Hence, here 80 divisions are there. So, hence, observe clearly. So, here 100 degrees rise of temperature in Celsius scale is equivalent to 180 degrees rise of temperature on Fahrenheit scale and 80-degree rise of temperature on Riemann scale. For example, here 1 degree is raised means what is the temperature degree it has to be raised in Fahrenheit scale, and what is the degree it has to be raised on Kelvin scale. What is the degree it has to be raised on Riemann scale means observe clearly. So if these are compared means here how many divisions are there? 100 divisions are there between LFP and VFP, and here 180 divisions are there. Hence 100 degrees rise on Celsius scale is equivalent to 180 degrees rise on Fahrenheit scale. Then 1 degree rise on Celsius scale that's equal to 1.8 degree rise in Fahrenheit scale. So if the temperature is raised by 1 degree Celsius on Kelvin centigrade scale, what must be the rising temperature on Fahrenheit scale means it must be 1.8 degree. And for example, if these two are compared means here 100 degrees are raised means here also 100 degrees has to be raised. That's why 100 degrees rising Celsius scale is equal to 100 degrees rising Kelvin scale. That's why 1 degree rising Celsius scale that's equal to 1 degree rising Kelvin scale. That's why the rising temperature in Celsius scale and Kelvin scale both are same. Here 10 degrees has raised means here also 10 degrees has to be raised. And what about Riemann scale means observe clearly in Riemann scale 100 degrees rising Celsius scale that's equals to 80 degrees rising Riemann scale. So then 1 degree rising Celsius scale that's equal to 0.88 degree rising Riemann scale. These are the change in temperature according to Celsius scale. So on Celsius scale, if the temperature is raised by 1 degree Celsius means what must be the raising Fahrenheit scale? It will be 1.8 degree Fahrenheit. And what must be the raising Kelvin scale means that is nothing but 1 degree Kelvin. What must be the rising temperature on Riemann scale means it must be equal to 0.8 degree. So these are the rising temperatures. So in further classes we can use these relations. Okay, so make a note up to here. Different scales of temperature, make a note. So here it is nothing but LFP. This is nothing but UFP. Write it this only, don't write this one. I will narrate. Okay, only different scales of temperature, write it this. Don't narrate, don't write this. I will narrate. Completed, Amma?
Sir, what are those values you have written in the last one? It's not visible, sir.
Which one? This one? Huh? This one only?
No,
Na?
sir. That the middle value. Value, sir.
Here?
No, sir. You have
This
written in between 80 and 0, no, sir. The
80
last
and
line.
this one?
That's not visible clearly, sir.
80 only this is. Here 80
Okay, sir.
divisions are
Thank you.
there between LFP and UFP on Riemann scale. Here 100 divisions are there between LFP and UFP. Here 180 divisions are there between LFP and UFP. Here 100 divisions are there. Okay. So make a note of here one point. So if 100 degrees centigrade, if the 100 degrees centigrade is the rising temperature on Celsius scale, is the rising temperature on Celsius scale. Is the rising temperature on Celsius scale. To have the same rise of temperature, it must be 180 degrees rise on Fahrenheit scale. It must be 180 degree rise on Fahrenheit scale. It must be 180 degree rise on Fahrenheit scale. Therefore, you can write this. 1 degree rise centigrade is equals to 1.8 degree Fahrenheit. The value of 1 degree centigrade must be equal to 1.8 degree Fahrenheit. So that is about this one. So next one is how to transfer the temperatures on different scales. Okay, so then how to transfer the temperature means, for example, here the temperature is some 28 degrees centigrade. This 28 degrees centigrade is equivalent to how many Fahrenheit? This 28 degrees centigrade is equivalent to how many Kelvin? This 28 degrees centigrade is equivalent to how many reverse? How to transfer the temperature values between one scale to another scale? Okay, so like this, how to transfer means we need a formula to transfer the temperature from one scale to another scale. So while transferring that formula is then what it means that. Say the reading, okay, reading minus LFP divided by UFP minus LFP is equal to constant. This is the formula. While we are transferring the temperature from one scale to another scale, reading of the temperature on that particular scale minus LFP upon UFP minus LFP equal to constant. For example, if C comma F comma K and R represent the same temperature on Celsius and Fahrenheit and Kelvin and reverse Kelvin, how can I write this? Let C is the reading on Celsius scale, the corresponding reading on Fahrenheit scale is F, the corresponding reading on Kelvin scale is RK, and the corresponding reading on reverse scale is R. So the C, F, K, R all are represent the same temperature, but in Celsius scale it's only C. The same temperature on Fahrenheit scale is F, and the same temperature on Kelvin scale is K, and the same temperature on reverse scale is R. Then how can I connect these letters means according to this reading minus LFP means so there what is the reading on Celsius scale? C minus LFP divided by UFP minus LFP is equals to reading on Fahrenheit scale is F minus LFP divided by UFP minus LFP is equals to reading on Kelvin scale is K minus LFP divided by UFP minus LFP is equals to what is the reading on reverse scale means R minus LFP divided by UFP minus LFP. So coming to Celsius scale, see what is LFP value on Celsius scale? 0 divided by UFP means 100 minus 0. And what is the F? Let it be F is the reading on Fahrenheit scale, F minus LFP on Fahrenheit scale is 32 divided by UFP means that is equals to 212 and LFP means 32 on Fahrenheit scale. Next coming to Kelvin scale, K minus lower fixing point on Kelvin scale 273 divided by upper fixing point means 373 minus 273 that is equals to. So reverse scale means R minus lower fixing point on reverse scale is 0 divided by UFP means what is UFP value here? 80 minus. So then the same expression can be written as C by 100 equals to F minus 32 upon 180 that is equals to K minus 273 upon 100 that is equals to R upon 8. So this is the relation which is used to transfer the temperature from one scale to another scale. So students, if we are transferring the temperature between Celsius and Fahrenheit scale, means these two are equated. If we are transferring the temperature between Celsius and Kelvin scale, this and this first quantity and third quantity will be equal. So among in between which scale temperature is transferred, the temperature is we are going to measure, those quantities can be. So this is about how to transfer the temperature from one scale to another scale. While we are transferring the temperature from one scale to another scale, this is constant. Reading of that temperature minus LFP of that particular scale divided by UFP minus LFP equal constant. Let C, F, K and R represent the same temperature on Celsius, Fahrenheit, Kelvin and reverse scale. Then I can write this equation in terms of the readings like this. So like this we can. So got it, guys?
Yes, sir.
Clear? Is that ma?
Clear, sir.
Yes,
So
sir.
first write it this one. While transferring the temperature, note down. I will close the session. Almost it is 12:57. Okay, so write it. While transferring the temperature between the scales, you can write this. Reading minus LFP by UFP minus LFP is equal to constant. Reading minus LFP by UFP minus LFP equal to constant. Next, if C comma F comma K and R, C comma F comma K and R represent the same value of temperature, on Celsius, comma Fahrenheit scale, Fahrenheit and so on. Celsius, comma Fahrenheit and so on. Okay. So we need not to write K and R. So K stands for Kelvin, R stands for Newton. Then you can write this one and this one and this one. Okay. You can write this. After that, we'll go with one example how to use this formula. Let us see. Okay, na? Is that over, guys?
Yes, sir.
So so please note down this problem. Please note down this. Okay. Convert the temperature of 40 degrees centigrade. Convert the temperature of 40 degrees centigrade on Fahrenheit value. Convert the temperature of 40 degrees centigrade on or into Fahrenheit value. Convert the 40 degrees temperature, 40 degrees centigrade into Fahrenheit value. So then here, so guys, look at that problem once. Please go through that. Okay. So what we need to do that. So they are given that temperature T is equals to 40 degrees centigrade. So it is in degrees Celsius. If this value is converted into Fahrenheit, means how much its value they are asking that. So here, what is this 40 degrees centigrade means? They have given the reading on Celsius scale. Then what would be the corresponding reading on Fahrenheit scale? They are asking that. So it means that C is equal to 40 degrees. What is the corresponding reading on Fahrenheit scale? So I am transferring the temperature between the Celsius and Fahrenheit scale means which two quantities can be equated? The first two only. First two only, no?
Yes, sir.
Yeah. So then I am equating these two quantities C by 100 that's equals to F minus 32 upon 180. So therefore substitute the reading on Celsius scale is 40 degree. 40 by 100 that's equals to F minus 32 divided by 180. So this 0, 0, this 0, this 0 gets cancelled. F minus 32 that's equal if 18 is taken to this side, LHS side, it will come into the numerator. Here already 4 is there, that's why I can write 4 into 18. So if this minus term is taken that side, that will become plus. So then F equals 4 into 18 plus 30. So 4 into 18 plus 32 means how much? Calculate
104.
1 not 1
Four.
not yeah 1 not 40. So hence so they have given that P is equal to 40 degrees centigrade, or else the T value must be equivalent to 104 degree Fahrenheit. So if the 40 degrees centigrade on Celsius scale is equivalent to 104 degrees on Fahrenheit scale. Like this we can convert from one scale to another scale. So we'll see the problems on the calorimetry different topics on tomorrow's class. Okay. Is it clear? Anything else you can ask?
No,
Yes,
sir.
sir.
Clear, sir.
Okay, na? Any doubts are there?
No doubt, sir.
No doubt, sir.
So, okay, see you on tomorrow's class. Okay. Have a look on the
Yes, sir.
topic. Okay,
Yes, sir.
Amrit.
Thank you, sir.
Thank you, sir. Bye, sir.
Yeah, bye.